Let's talk more about the binomial theorem. Here again I have a binomial, a plus b, it's got two terms, it's to the n power. And I've drawn Pascal's triangle here, filled in with the variables a with their exponents and the variables b with their exponents. Remember that the top of Pascal's triangle is a plus b to the 0 power, a plus b to the 1, etc., all the way down to this row, a plus b to the 5th. Let's take a look closer at a plus b to the 5th. Notice I know it's to the 5th because my first non-1 coefficient is a 5, so I know I'm down at the 5th level. Well, it's actually the 6th total, but I know my exponent is a 5 because my next to the 1 I have a 5 there. Well, we've seen from Pascal's triangle that we have a 5, 4, 3, 2, 1, and then b goes 0, 1, 2, 3, 4, 5 in terms of its exponents. And if we're using Pascal's triangles, we can certainly generate the coefficients. 1, 5, 10, 10, 5, 1. Well, remember that when we do a combination, order doesn't matter, and it's NCR means n factorial, the total number you're choosing from, choosing r out of n will be n factorial divided by n minus r factorial times, in the denominator, r factorial. Well, we can use combinations to figure out these same coefficients. This would be 5c0, 5c1, 5c2, 5c3, 5c4, and 5c5. Which gives us, here is the binomial theorem, here gives us 5c0 of a to the 5th, b to the 0. Notice the 5 comes from 5 minus 0, and whatever is here, your r is going to be the exponent of the b. So 5c1 would be 5 minus 1 is 4, and the 1 goes to the b. 5c2 is 5 minus 2 is 3, goes in the exponent of the a, and the 2 becomes the exponent of b. 5c4, the 5 minus 4 goes to 1, and 4 is the exponent of the b. And 5c5, 5 minus 5 is 0, and 5 goes to the exponent of the b. We can now talk about the general term of the binomial theorem. We saw before, here's our binomial, a plus b. Instead of to the 5th power, now we're going to take it to the nth power. And we're going to have different terms. Term 1, term 2, term 3 here in red. Well, we're going to always start with nc0. I don't know what my n is, so it's just a variable n, of n minus 0 will be the exponent on my first term of the binomial, and this, whatever's here, 0 in this case, will be the exponent on the second term of the binomial. Then we go to nc1 of, again, n minus 1 is my exponent on the first term, a, and whatever here, 1 goes to the exponent on the second term, b. nc2 is n minus 2 is the exponent on a, and 2 is the exponent on b. All the way down to the general term, ncr will be, n minus r will be the exponent on a, and r will be the exponent on b. And last, we're going to finish with b to the n. Whatever n is, it'll be just 1b to the n. We saw that in Pascal's triangle. On the outsides, 1 is the coefficient both to start and end the sequence or the series. Well, what else can we see about this? The first term, t1, has c0. t2 has a c1. t3 has a c2. Term 23 has a c22. Notice that whatever your NCR, this is the R here will be 1 behind your term. If the term is 1, the R is 0. If the term is 2, the R is 1. If the term is 3, the R is 2. We can now continue on to talk about the general term. We see that TR, some term R, is NCR minus 1. That's the relationship. If we're talking about the 23rd term, then we'll have 22 here. If we're talking about the 50th term, that will be a 49. If we're talking about the second term, that will be a 1. NCR minus 1, a to the, well then it will be n minus whatever's here. N minus r minus 1. B to the, well whatever's here will go there. So if that's the case, then we could add 1 to r here. So instead of looking for the term r, we can look for the term r plus 1. Which will require us to do nc r plus 1 minus 1, a to the n minus r plus 1 minus 1, b to the r plus 1 minus 1. Of course, the plus 1 and the minus 1 cancel out in all three cases, so we get t r plus 1 is equal to ncr, a to the n minus r, b to the r. Well, what's the most important thing? Do you have to memorize this formula? which I put in stars in blue and red? No, but you just have to recognize that if you're looking for the 50th term, this will be a 49. It's just another way of saying, if this is the 72nd term, then we're going to have a 71 here. And always, your first term will be n minus r there, and then whatever's r will go there.